All right, lesson 10.2 is permutations and combinations. Before we get into actually the lesson, I wanted to spend a little bit of time just reviewing what we discussed in lesson 10.1. So I have a couple of questions, so if you could pause the video at this time and go ahead and answer these two questions. All right, question number one is, in how many different automobile license plates can be made if each plate has a letter followed by 3 digits? Now remember, when we did these, one thing that you always need to be careful of and mindful of is, do the digits repeat? And you're always going to want to assume that the digits are allowed to repeat, or the letters as far as that goes, unless we specify otherwise. So remember, the first thing is we're going to make just a sample. So we've got a letter followed by 3 digits. Okay, so we're going to do a letter followed by 3 digits. And you always got to think about, okay, how many letters do I have in the alphabet? How many choices do I have to put in that spot? And we have 26. How many digits do we have? And remember, our digits are the numbers 1 through 9, just single 1-digit numbers. Once we get into 10, then it's a 2-digit, takes a 1 and a 0. We also want to include 0 in this spot. So we actually have 10 choices. And since they can repeat, so in other words, if I use the number 6, I can use the number 6 again. So this is actually going to be a 10. And the last one's a 10. And remember, the fundamental counting principle says we simply just multiply. So 26 times 10 times 10 times 10 gives us a total of 26,000. Okay? All right, question number 2 says, Roscoe Flatts has 3 number 1 hits off their Still Feels Good album, 5 from their Me and My Gang album, 2 from their Feels Like Today, and 2 from their self-entitled debut album. How many possible ways could they arrange the songs from their albums into one greatest hit song? And we're going to assume that they're only going to select one song from each album. Well, first of all, they have 3 from their Still Feels Good album, 5 from Me and My Gang album, 2 from their Feels Like Today, and 2 from their self-titled debut album. Okay, so if I wanted to pick a song, so I have the one that Still Feels Good, and I have 3 that I can pick from that one. Me and My Gang, I can choose 5 to put in that spot. From their Feels Like Today album, we have 2 that we can choose from. And then from their self-titled debut album, we'll call it, they can do 2. And remember, the fundamental counting principle says all we have to do is multiply those numbers. So if you multiply 3 times 5 times 2 times 2, they have 60 different ways that they can make an album. Okay? All right, well, I currently have a couple of activities that I want us to do as a group. All right, and if we remember from yesterday, here's the first activity. So if we had a group of 3, we want to list all the possible ways that we could arrange those members in that group. So let's say we've got member A, we've got member B, and we've got member C. So go ahead and pause the video at this time, and I want you to list out all the possible outcomes that you can come up with. And when we do this through the video, go ahead and start marking them off to make sure that you've got them all. If you're missing any, then go ahead and include those. All right. So in the first one, like I said, we have a group of 3. So we have group A, group B, and person A, person B, and person C. And we want to list all the ways that we can arrange or just rearrange the members in that group. So I could do ABC, just like we did. I could also simply, if I'm just rearranging people, I could switch C and B. Okay. I could actually pick person B first, then I could pick person C and person A. Okay. Or I could simply switch C and A. Another possible outcome would be if I picked person C first, then person A, and then person B. And then again, I could just switch the last 2. Okay. Now this is really no different than yesterday, like when we said how many ways can 12 racers finish the race in the last lesson that we did. So think about it. So you're trying to put people, just rearrange them in seats. How many choices do I have for the first seat? Well, I have 1, 2, 3 choices because I haven't put anybody in that seat. So somebody sits down. Once somebody sits down, how many do I have for the second seat? Well, somebody sits down. Now we've only got 2 choices. 2 people sit down, so we've got 1. Multiply those. 3 times 2 times 1 gives me a total of 6. And if you count them all, 1, 2, 3, 4, 5, 6, means we've got them all. All right. So look at the second activity. Now, the only difference in the second activity is we have a group of 4, but in this group of 4, we want to know how many different ways can we pick a president and a vice president out of this group of 4. Okay? So we're going to pick a president, and then we're going to pick a vice president. Okay? So if I use the same, we'll just call person A, person B, person C, and person D. Okay? So I could have person A be the president, person A is the president, person B could be the vice president. Or I could have person A be the president and person C be the president or vice president. Or I could have person A and person D be the vice president. Okay? Now, if B gets elected president, we could do the same thing. We could have A be the vice president, C could be the vice president, or person D could be the vice president. Okay? And the same pattern for C. So we'll do these real quick. So if I have C, then I can have A be the vice president, I could have B be the vice president, or I could have D be the vice president. And my last combinations would be if person D is elected president, then I can have person A be the vice president, person B be the vice president, or person C be the vice president. Okay? And if I count all of those ways, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 different ways that I can arrange, different combinations that I can actually come up with when I'm solving those. So this is really no different than what like I said, we did yesterday. So, because if you think about it, how many choices, if we're going to elect a president first, how many choices do I have for picking that president? Well, I have 4. We haven't picked anybody yet, so we have 4 people that we could pick. We pick the president. President can't be the vice president. We have to have somebody completely different, so we put somebody in that spot. Now, how many choices do you have? And we have 3. So we simply multiply those. 4 times 3 gives us 12. Okay? Now, the last activity is a little bit different, because in the last activity, all we're going to do is we got the same 4 people. Person A, person B, person C, and person D. And we want to list all the possible ways that you can create a subgroup out of 2 people. So let's say this was members of a committee, and we're going to create a subcommittee. Okay? Now, one thing that you got to remember is, so let's just do these real quick. I could pick person A and person B. Okay? I could pick person A and person C. Person A, person D. Okay? Now, the order at this point, okay, we have different outcomes. Person A is matched up with somebody different on each subgroup. Now, here's the question. If I pick person B first, if we're just sitting around the table, 2 people just to sit and have a conversation, and then I pick person A. If you're looking at the table as a group, when you're sitting around that table, is that a different combination or is that the same combination? And you quickly find out that, hey, wait a minute, that's the exact same combination. Person A, person B. Didn't matter who I really picked because they're both sitting around the same table. So we're going to throw out, in this case, any repeats because we're not putting them in any specific case. But person B has not been placed with person C, and person B has not been placed with person D. Okay? And then you do the same thing with C. Well, you realize that C's already been matched up with A. C's already been matched up with B. So the only combination it has is C can be matched up with D. And then if you look at D, well, what happens if I pick D first? Well, D's already matched up with A, D's already matched up with B, and D's already matched up with C. So you quickly find out we have 3, 4, 5, we have 6 different ways that we can pick 2 people out of 4 people. Okay, we were just picking 2 as a group. Okay, now here's the main difference. Okay, so this is probably the most important slide to help you keep these 2 concepts separate. Okay, so from a group of 4, how many ways can a president and a vice president be selected? Okay, this is called, so this is one where we're going to do the president and we're going to do the vice president. Okay, so we have 4 people that we can pick. Once we pick one, we have 3 to pick from, multiply them, and we have 12 different ways that we can get that out. Okay, just like we did in activity 2. This is called a permutation. Okay, on permutations, the order matters, or it is important. Okay, in other words, if you remember when I picked person A and person B, and then if I pick person B and person A, those are 2 different outcomes, because in the first case, person A is the president, person B is the vice president. In the second case, person B is the president and person A is the vice president. So those are 2 different outcomes, so you have to count those. Now in the second scenario, the one on the right, we're looking at, we want to create groups of 4. But if you remember, the answer to this one was 6. So in the first spot, I have 4 people that I can pick from. Let's write it up there. And for the second spot, once I put somebody in that first seat, now I have 3 people that I can choose from. And if I multiply those, I still get 12. But remember, when we had person A and we were choosing person, if we had person A first and then person B, if we're just choosing them as a group, the order is not important in this case, because we're choosing, like I said, we're choosing these as a group. So the order in this case is not important. And so we have to make sure and take out those repeats. And the way you take out those repeats is we've got 2 spots to fill. So you're going to divide by 2 factorial. Well, 2 factorial is 2, so your answer ends up with 6. Okay, and this is called a combination. Okay, so when you're doing these, the first thing that you're going to have to do is you're going to have to make sure and take a look and say, okay, is this problem a combination or is it a permutation? Do I want them as a group, or am I putting them in specific order? Okay? All right, so let's take a look at the first example. First example says, find the number of ways to take 20 objects and arrange them in groups of 5 at a time where order does not matter. Now, there's a couple of keywords in here. Okay? If we're dealing with permutations, let's match it up with the other one. So we'll do permutations and combinations. Okay. Now, if you remember, we're talking about groups, and this problem already tells you that the order doesn't matter. So if you look back at our cheat sheet, the one that's order is not important is a combination. Okay. Now you're going to start off by solving these the exact same way. So this one is a combination. Okay. So we've got 5 spots to fill. Okay. In the first spot, you have 20 people to pick from, because we haven't picked anybody yet. So you have 20 people to pick from. Put somebody in the first seat, now we have 19. And then we have 18, 17, and we have 16 for the last spot. But remember, because this is a combination, and so when we rearrange the same 5 people, we don't really care about that, because we're just, like I said, putting them around the table. So we got to take it around, and we have a 1, 2, 3, 4, 5 factorial. So the 5 factorial takes out all of the repeats. So now if you have a scientific calculator, that's where this is going to be really, really helpful. All right, so if we have a scientific calculator, we're going to take, and you can put all of this in here together. You're going to put all of this, make sure you put this in parentheses, because we're dividing all of it by, we're dividing it all by 5 factorial. So we're going to do 20 times 19 times 18 times 17 times 16. And then we're going to divide that by 5 factorial. And if you look, this right here looks very similar to what we did over there. And you hit an equal button. This thing will do all of the work, and you find out your answer is 15,504. Okay? So you have 15,504 ways that you can arrange all of the people. All right, take a look at example number 2. Okay? Make our little cheat sheet, permutations or combinations. So how many ways are there to select a subcommittee of 7 members from among a committee of 17? So you got to think about this. Am I putting them in specific positions, or am I wanting the group as a whole? Okay, and there's always keywords that you need to look at. And this one is subcommittee. So that automatically tells me that I'm creating a group of people. So when I'm creating a group, I want a combination, okay? Because the order isn't important that I'm going to pick. So I've got 7 spots. 1, 2, 3, 4, 5, 6, 7 spots. The first spot I have 17 to choose from, 16, 15, 14, 13, 12, and 11. And remember, because it is a combination, I'm going to divide by how many? 1, 2, 3, 4, 5, 6, 7 factorial. However many numbers there are divided by that 7 factorial. Okay? All right, so just like the last one, let's clear this out. So we're going to do 17 times 16 times 15 times 14 times 13 times 12 times 11 divided by 7 factorial. Hit the equals, and we get 100. Oh, wait a minute, we got an error here. Let's try this again. 17 times 16 times 15 times 14 times 13 times 12 times 11. There we go. And then we're going to close it and divide by 7 factorial. And we find out we get an answer of 19,448 different ways we can create a subcommittee consisting of out of a committee of 17. Okay? All right, so take a look at example number 3. Example number 3 is, in a local election, there are 7 people running for 3 positions. The person with the most votes will be elected president. The person with the second most votes will be elected vice president. And the person with the third most votes will be elected secretary. How many different outcomes can this election have? Well, since we're actually putting people in specific positions, president, vice president, and secretary, that automatically should tell you that, hey, that's a permutation. And remember, permutation is important because if I have person A, person B, and then person C that wins, and a different outcome could be person C, person A, and then person B. It's the same 3 people, but we're going to count the outcome because they're in different positions. This person is president, and here person C is president. So this is really no different than what we did under the fundamental counting principle. So the president, there's 7 people. So sometimes you have to pull out some of those numbers that you need. And we got 3 positions: president, vice president, and the secretary. And once we know who gets the most votes, we're going to put that person in there. So then we have 6 more people that can win second spot. So now that we've got the person that won first place, second place, then we've got 5 that can choose to get third place. And when we just multiply those, so 7 times 6 times 5, gives us a grand total of 210 different ways that we can have an outcome in this election. Okay. All right, go ahead and take a look at the last word problem. And then there's some just basic problems that I want us to take a look at. An exacta in horse racing is when you correctly guess which horse will finish first and second. If there are 8 horses in the race, how many different possible outcomes for the exacta are there? Well, when you're looking at this, first of all, we got 8 horses. And because we're putting them in specific positions, we're putting them in first place and we're putting them in second place, it's going to be a permutation. Okay, and remember, permutation is important because in one outcome, horse 1 can win first place, but in the next outcome, it could win second place, and whatever won second place can win. We could switch the positions. Okay, so I have no horses won the race yet, so I have 8 horses that can win the race. So I have 8 that's won. So in the last race, I have 7 that can choose. Multiply those just like the fundamental counting principle, and I get 56. So you just have to remember that when you're choosing a permutation, you do not divide by the repeat. Okay, we don't want to take out those repeats, so we want to keep all of those repeats in. So when we multiply them, it'll keep the repeats in. It also counts when they rearrange them. Remember, on a combination, when we're talking about just the group, then we want to take out the repeats. And that's how you divide by however many numbers there are factorial. So just a couple of basic problems I wanted to cover real quick. This is a lot of notation that you will actually see. This stands for 7 permutation 4. This is 5 combination 3. The P and the C stand for permutations and combinations. The second number tells you how many spots you're filling. Okay, so there are 4. Okay, this number tells you where you start. So you're just going to go 7, 6, 5, 4, and then just multiply them. 7 times 6 times 5 times 4. And remember, on a permutation, we do not divide by that extra factorial, and you get 840. Okay, on a combination, the same rule applies. We're filling 3 spots. We start with 5, 4, 3. But remember, on a combination, we have 3 numbers. We have to divide by the 3 factorial to take out the repeats. And that gives us an answer of 60. Okay. So as a quick recap, and this is probably a valuable information, you have to remember that permutations is when the order is important. Okay. The order is important. You're looking at, you're determining placement in a race, first, second, third place, etc. You're also putting people in positions: president, vice president, secretary, manager, assistant manager, things like that. Combinations is when the order doesn't matter, and so you got to remember we've got to take out the repeats. So we're going to take out repeats. And in order to do that, you're going to divide by the factorial. Okay? And typically some keywords that you're going to look for when doing that is group, committee, or subcommittee, or if they just flat out say that the order is not important. So those are some keywords that you're going to look for. Okay?